Let's take this problem of translating scoring into an AI model. What would be your recommendation for the best collaboration between computer scientists and pathologists? How do pathologists explain this scoring best to the computer scientists? And how should computer scientists, what do they need to know? What are the requirements from both sides to solve this problem?
Of course, you can teach this kind of classification, but it's always better that it can be converted to area of something or count of something. This kind of numeric exact things that you calculate area of tumor area inside of stroma or whole tissue, this kind of tumor burdens. It needs a discussion between the pathologist and computer scientist. Can it be converted this kind of exact pixel number, so area of micrometers in pathology or number of cells?
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Hi everyone. Today's episode is sponsored by Aiforia. Aiforia stands for AI for image analysis, and Aiforia's deep learning AI and image analysis software equips pathologists and scientists with the most powerful cloud-based technology to advance their image analysis. Today my guest is Tuomas Roponen, the Chief Technology Officer at Aiforia. Hi Tuomas, how are you today?
Hi Alexander, thanks for the invitation and nice to talk with you.
Thanks for joining me today. Let's start with you. Let's start with you're the Chief Technology Officer at Aiforia, but tell us about your background and how you joined the company and what is exactly your role in the company. What does a Chief Technology Officer at Aiforia do?
So first for the background, so I studied in the Technical University of Helsinki, computer science, machine vision, software development, robotics, self-driving autonomous cars. Actually, from my master thesis, I did it from machine vision, and we started the first company doing machine vision system for the heavy industry, like automotive and paper manufacturers. So I have a 20 years history in software machine vision, creating products, not research. And actually, the university that I studied, the invention of backpropagation, the algorithm that is used for neural network teaching, the invention was done 51 years ago. It's the first known implementation. So there's a long history in that university for the neural networks, much before the hype.
Which the hype is just like the recent, 5-7 years, not even 10 years.
5 years is maybe the hype, or 7. There has been a couple of hypes before already, but this is maybe the second hype or third hype of the neural networks. So every technology has this hype curve, of course, and now we are maybe in the upper corner. Let's see.
So you said you worked in product development in different companies. How did you join Aiforia? Because what you said before, it had nothing to do with pathology. And then what motivated you to join a company that is providing services for pathology, actually?
Actually, I met a couple of one of the current workers that were in the starting of the Aiforia. They work at this kind of medical device robotics company that was doing automatic pipetting. I was there leading the software team there. So I have changed the company, and they asked him, do you know anybody that would like to come to us? And I said that I know myself. So I joined the company.
Okay.
So because I knew that it is 5 years ago when I started this company. So I knew then that the deep learning is just coming and it's ready for the commercial use, not anymore academic research. And it was a good time for me to join the company.
So you joined as the Chief Technology Officer. What are you responsible for as Chief Technology Officer at Aiforia?
Basically, I'm leading the software R&D, that is tightly related to AI R&D. So also testing the neural networks, doing a lot of practical things together with pathologists trying to build the platform for them. CTO has many roles in small company.
Yeah.
But main job is leading the AI platform development, not just the models or the software.
So Aiforia has a cloud-based artificial intelligence for image analysis platform for pathology. It was founded in 2013. First, let's start with what drove the decision for the platform to be cloud-based, because I don't think there was anything cloud-based in 2013, and now, even though it is a great technology, not everything is cloud-based. Why did you decide it should be cloud-based, and how did you know?
Actually, the history of the product is much longer than the 2013. So it was under University of Helsinki, maybe beginning of 2000. And the platform, this kind of image sharing platform, started with teaching the medical student of the pathologists, and this kind of seminars or example. I just found that the 2006, the ECP, European Pathology Conference, was hosted by the former name of Aiforia web microscope. So that's actually almost 20 years history of this platform. Okay. But it was under the University of Helsinki, or the FIM is the Finnish Molecular Institute, where the origin, where this basically this company is spin-off for that platform. So it has been run always in the cloud or server-based, web-based system.
So basically the origin was telepathology, was sharing images remotely. And then
yes,
on top of that, the image analysis capabilities were built?
Yes, and the origin is this image sharing telepathology type of platform for research use. And I was hired 5 years ago to build the AI platform top of that. So doing the AI functionalities are needed for AI development. Because I think that the cloud-based system is, if you think about AI, it's about teaching. And who is the teacher of AI in pathology? So pathologist. So you need to have easy access to see what AI has learned and how to do annotation. The teaching is done by annotating. So if you have some server that is basement of some company, how to get easy access for the pathologist. So having a web-based system that runs in the cloud solves the many practical problems to how to teach AI, how to get pathologists easy access to AI teaching.
And how did you know that it's going to be supervised deep learning? Because again, okay, you said that the origin of the company and origin of the product is even before 2013, the official foundation of the company. It was only in 2012 that the deep convolutional neural networks started outperforming the classical image analysis method, classical computer vision method in the natural image processing challenges, this ImageNet challenge, one of the famous one. How did you know in 2013 or 5 years ago when you joined that it's going to be supervised deep learning?
So there's many, if I talk about unsupervised, everybody wants to have an unsupervised AI. Basically, you draw just data and it tells you what to do. I wouldn't really recommend that with cancer. Do you let your kid to internet and self-learned what is the world? So we don't let humans to be in unsupervised learning. It's strictly supervised whole school system. So there's many practical problems with unsupervised learning. Everybody wants to do it because it seems that easy. Just throw data and it self-learns the stuff. There's really few practical applications that can be done with unsupervised learning. And you will get, if you can create ground truth, what is cancer, what is benign, then the supervised learning will beat that always. Of course, the practical problem is with the supervised learning is that how do you get the ground truth? How do you can get the access from the pathologist knowledge? How can pathologists annotate what is cancer or benign, what is in the border? those are the challenges in the supervised learning, and because pathologist time is really limited, that can try to always minimize. And why the convolutional neural network? I think that it's the competition wins both. There's a couple of independent, one German that actually they did the mitosis counting in 2012 with convolutional, it was ImageNet. So at the same time, actually the invention of convolutional, I think it's convolutional deep neural network was the reason. So it can, and also creating practical tools that it can be taught with GPUs. So you need a lot of computational power to teach convolutional neural networks. And also there was a lot of libraries coming out that you don't need to hard code it. Basically, you don't need to have a lot of coders to do how to teach AI in GPUs. So that there's a lot of these small things that happened in 2012, 2013, 2014. So it was ready for this kind of commercial application. I think that because of it doesn't matter what is the system that you want to teach AI human. So you need to have the good study book. And basically what the are doing, they are creating the not rules, but the book for the AI, what needs to be studied. Examples of the cancer, examples of benign, example of mitosis, what is trauma, what is epithelium, what is not related, what is basically different type of tissue like lung tissue, prostate, or so there's a lot of subdomains even in the pathology world. And you need to basically draw it. That's the best way to teach it.
Yes. So you are on the technology side of things, responsible for leading the product development, all aspects of product development. First, was this always meant to be for pathology, or was it for some other medical imaging at the beginning? You said that the founders were at the company that was using machine learning for different purposes, for pipetting. Was it pathology from the beginning?
Pathology for this company, Aiforia, it has been pathology for the beginning. So the Molecular Institute so it's research institute in Helsinki University, they have been digital pathology was the main platform. So for this company, it has been always the pathology first. Because we can do pathology, this technology actually fits really well also for the satellite imaging. That's really close to technically to pathology. Basically, what is forest? What is area? How many rivers? What is the stroma? So there's a lot of analogy in, and same technical problems that damn large images that doesn't fit any computer memory, or really few memory can handle those. So similar, and you cannot see the data in one glance. You need to zoom in, and so technically it's same than satellite imaging, the pathology tech side.
So how was the initial process of matching this technology, the Aiforia technology, to the needs of pathology? And what was your experience in this, coming from a non-medical background, non-pathology background?
So maybe the key text that we match it so that you need easy access for the pathology. So no need for any software installation or go to some basement to some dedicated computer. So web browser is basically the technology side. So user interface has been always been in the website. It's difficult to make it working as efficiently on the desktop computer, but the easy access is really crucial when you are teaching the AI models. If you have multiple example, one prostate pathology from US and one from Europe, and they need to create consensus or check that does the AI model work. So how do you create that easy access for AI? And pathology is actually doing, at least in digital pathology, the annotation is part of the work, not maybe AI for AI, but marking the tumor area for the diagnosis. So annotation is the communication method with the AI. Because you're communicating already with the annotations, then you need the supervised technology, and the state of the art is at the moment and was 5 years ago, the deep learning convolutional neural networks. So easy access, state of the art technology is the key crucial choosing points.
So when you started and you gave this tool to the pathologists, how were they working with you? What were the problems that you encountered, both on the technology side and on the pathologist side?
Actually, there's some commonness in between pathologists and computer guys or computer nerds, scientists. We like details much more than maybe marketing persons. So there's similar mind and maybe more technology than humans. That's average. Radiologists, pathologists, computer guys, and maybe a little bit different to average persons. So that's much more common, I think. But of course, the language and ways of working are quite different. Language, I mean, thinking that I was in the first meeting with the maybe 8 pathologists trying to, they explained this is trauma and this is epithelium, and then I understand this is a forest and these are the agricultural fields. So I needed to have a common language, and I can recognize the patterns in the image, but the terms of the pathology was totally new for me. And the pathologists laughed at me, but they were really happy that they found common language.
This is great.
So there's a lot of analogy in the satellite world, maybe. And that was the easy way to start. Of course, I know now basic terms after 5 years, but still there's 90% of the pathology terms is not familiar. So having common language is important to success.
Definitely. So you found, so both the computer scientists on your side and the pathologists, you found a common language that helped you work together. You kind of figured out how to translate the pathology pattern names or the patterns into something that you knew. You said satellite images of forests, of rivers and geographical formations. So the communication crucial. I never looked at it from that point of view, that actually regarding maybe character and personality, there are a lot of similarities between computer scientists and pathologists. So once you figure out a good way to communicate, then it's actually not as difficult and as you would imagine.
That's actually, I think the personalities are much more similar than the previous so-called customers that or partners when we are making the software. That's quite unique. And when you're talking to communication, because of course, computer scientists and coders need to understand where they are developing the platform, and also this technology needs to be taught also to pathologists. So there's a lot of hype in the 2012, 2013, 2014, because a couple of major companies maybe over marketed the AI. So everybody thought that AI is this magic box that you draw data and images and it tells you what is the cancer and not cancer. And that was totally untrue for my side. So there many people still think that you buy AI and you don't need to communicate, it just does the work. But actually it's a lot of in Aiforia, our pathologists are teaching the AI, not the computer science. 90% of our work or the AI model teaching is done totally without computer scientist or machine learning engineer or machine learning scientist. The idea was to teach that we created a platform for pathologists to teach the AI. Of course, there's a cultural difference that now in our company, the pathologists are actually R&D developers. They are teaching the AI, so they are developing the AI model. And that's different culture than clinical pathology or even research. What is agile and Scrum and Kanban, this kind of computer, where the computer nerds are familiar, this ways of working in R&D. And also a little bit teaching that what are the basic principles of AI or deep learning. But that was the easy part. The communication is the most crucial. And still, I think the pathology is basically, if I understand, the last 400 years, it has been same, viewing from the microscope.
Yes.
Digital pathologists even knew. So maybe not all the pathologists are so familiar with computers and computer stuff.
Hmm.
So actually, it's damn large revolution for the pathology,
Uh-huh.
changing in a couple of years or 10 years.
Hmm. But you say, okay, so from the pathology side, it was more or less the same process of like they were building another part of the bridge. They had to learn what is Scrum, what are the steps of software development, I guess. Also, a little bit about deep learning. It's interesting to hear that. So there is a little part from each side regarding the basic knowledge, but then the main part of this bridge is the communication.
And actually, even the FDA is recommending that in the AI pipeline, you need to have this kind of quality review. And who is the person that can do in pathology the quality review? It's the pathologist. The only person that can check that does it recognize a cancer or not, who is qualified. And actually, in that process, that good machine learning process, or pathologist is still needs to be in the loop, even the development of the products and continuous improvement. Like Tesla is improving all the time their self-driving car. So I don't believe that when you buy now AI that it will be the best possible, because everybody knows that if you give more teaching material, high quality material from the pathologist, it will be better. So if you can save lives creating better, more AI model or AI product, I think that it needs to be continuously improved. And if
Mm-hmm.
something changes in the pathology and medical domain, you recognize some biomarker, or you actually, I think that because the AI makes the possibility to read slide in every pixel, so it can give also a lot of information for the pathologist that was impossible to produce before. There's not enough pathology to do it manually.
That's true.
It will change the research in many medical domain, or not medical, but I mean pharma research, medical drug and also this kind of outcomes. What is the best treatment for different type of tumors? There's a lot of
Mm-hmm.
this kind of research that it's not yet have been done that can be done with the AI. There's a lot of learning from the pathologist to utilize this technology. You don't need to be super expert in deep learning. It's basic principle of teaching something. Even it's similar to teaching humans.
Mm-hmm.
During this
Mm-hmm.
company, my boy has been gone from 1 year old to 6 year old. That is actually a bit similar than AI when he's learning, at least in the beginning.
Mm-hmm. So in the daily business at Aiforia, what are the ways or processes when in your daily work to stay aligned with the pathologist working on projects or on the product itself? Because you say they are using it continuously, so I assume they like communicate what the user requirements are, what the improvements should be. What are the processes for communication? Like when you sit together, how do you do it?
Actually, when we started this office and hired first pathologists to be, they were basically next room from the coders. Actually, there's one wall between. So creating a small team that doesn't have this kind of barriers, that was really important in the beginning. This COVID situation has a little bit changed the situation, so we have transferred the digital Slack messages, but still there's this kind of open channels that the pathologist, or we have microbiologists and medical students that are using our platform daily, that they have easy access to tell what is not working, what should be working. And now, of course, we have the UX designers are crucial in addition to that team. So coders are not maybe best always think that what is the user interface to use AI or teach it. So we have between the coders and pathologists, user experience designers that are familiar with talking different so-called domains and interpreting the needs. But still the direct conversation with the UI developer and pathologist, or the AI developer or AI scientist and pathologist I think it's crucial. And before that, of course, you need to have the common language.
Definitely. So how often do you release new version, more or less?
I think the new version for the internal users, maybe weekly.
Oh, weekly.
Yeah. So be a rabbit.
Okay, yeah, that's frequent. That's very agile development.
That's for the internal users. But of course, end customers are getting. So pathologists are in our house also our so-called testers, testing the AI models, testing the user interface. So they're using not this kind of polished product always. So it's better to get the feedback as fast as possible because we are in competition against many, not many, but some companies. So we want to be agile. And if you have an in-house pathologist team that is using daily the product, you are not afraid of the updating the product. Of course, we will test everything, but still updating. So they will get the new features to be tested. And if it doesn't solve the problem, we get the feedback immediately and can cancel the feature, improve it. Or if it's good, then we can push it to the official production releases that are done maybe 4 times a year.
Mm-hmm. This is really fast and a great process. I love to hear that you're working with pathologists like that because this is immediate feedback from the users. This is really amazing.
It can be done also only this kind of research environment, not clinical workflow, this kind of factory like that we are getting 1,000 patients a day. But in research use that our pathologists are using for medical research, publications, teaching the AI models for the research use, then we are getting this option to get the feedback much faster. And I think that it's crucial when you are developing.
Mm-hmm. And to get the feedback, do you have daily meetings, weekly meetings? Do you don't have meetings, you just chat on Slack, or how does this happen?
Before the COVID, there's a lot of this coffee room discussions, and because there was basically 1 meter or 2 meter between the pathologists and coders, so it was really easy. And of course, there's official weekly meetings between the teams or team leaders, and also keeping all the time the open channel. We are using Slack as a messaging software, and we have open channels for the AI development, software development, image analysis, clinical development. So having these kind of direct conversations grouped with these kind of channels is, I think, the COVID way of working. And also because we are not anymore, all the people are not from Helsinki or Finland. So the electrical, so-called Slack messaging and those are much easier with this kind of growing company.
Definitely. In this process, can you tell me about a misunderstanding between the pathologists and computer scientists that you had, something that you had to solve, and how did you solve it? Something that caused trouble.
One of the first AI models that I was personally doing the annotation actually even was fat liver.
Mm-hmm.
So it's basically white holes in the liver tissue. So it's not technically.
Yes,
And then,
but I mean, this is how you have to translate those patterns to people who are not pathologists. You basically describe what it visually is. So exactly, white holes. The fatty vacuoles in the liver look like white holes.
actually, one analog for the white holes is that actually in concrete industry, there are some bridges fallen down and they are staining the concrete with this kind of same color than hematoxylin, so this kind of pink. And the white holes are when the water comes out of the concrete. So more you have holes, the more brittle, easier the bridges will collapse. So they're actually doing same measurement in concrete industry, so white holes in the image. But in pathology, you have then more fat in the more brittle liver.
Mm-hmm.
But the miscommunication is that I worked a couple of days because unnecessary maybe, because I was afraid of asking pathologists. I got a list that this has now 20%, 70%, 50%, 60%. The pathologist was scoring the liver
Mm-hmm.
based on percentage. Then I had an AI model that calculated exactly the pixel areas of the fat cells compared to liver tissue. I got percentage from 0.5 to maybe 16%. So none of the numbers for 100 or 80%. And I was, why my AI model doesn't work at all according to ground truth. So then it was basically hard lessons that pathologists are using normalizing sometimes the scales. So most severe fat liver can have 90% fat. But actually, if you calculate the pixel areas, it's 16%. Because between the fat cells, there's a lot of tissues. So maybe the misunderstanding is easily that some of the scoring systems are this kind of, in pathology, they are not exact pixels because no pathologist will draw every area or count pixels. And sometimes the scoring systems are differently normalized. So most severe cases, the highest score, and less severe is the lowest score. But what is the scoring system in pixels? That's easier, quite easy to make a misunderstanding. And it's on some publication, it actually proved that the pathologist always when we showed the results, then the pathologist or medical experts say that it can't be 16%. So they don't believe the results of the pixels because they have always normalized the tissue. And then we needed to do this kind of blind checks that we draw the pixel area in this kind of manual tool of the fat cell. And before asking that, what is the score? They said 80%. And when we draw the Excel pixel areas and they can see when we measure it, and it actually 20% or 16%. And I think that many of the grading system in pathologists are normalized somehow in the medical domain. So they are not exact these kind of numbers of cells or areas.
Yes, so this is a very important thing that you're mentioning, the translation of pathology scoring into even before the scoring is output from an AI model into building a model. This is, I think, an art of its own, and this is where communication between pathologists and computer scientists is even more important than for all the other things, to avoid the misunderstandings, like you said. Very, very interesting.
That's crucial for the. I have met a couple of times after that same, because I have read many of the scoring systems, and still the liver fat was the easy explanation because I thought that it's the pixel area, but when a computer guy talks, it's area of pixels or area of micrometers or count of objects. But some of the scoring systems are not exactly that. If you think about Gleason grading, you have different patterns, or melanoma grading is much more difficult even. And computer guy thinks that, example, if you have 5 grade systems, you have severe, benign is maybe 0, and 1 is the starting malign, and then the first cancer is 2. For example, in melanoma, the agreement with the pathologist, it's difficult problems to estimate things, and computer guys are calculating exactly and translate that to so I think that many of the scoring systems cannot be taught directly to the AI. One thing that in real world, when we talk that the scoring systems are this kind of grading systems, they are normally this kind of continuous. When the cells or tumor start to mutate, there's no exact borders. There's always something between, so it's a continuous curve. Actually, it should be a number like Gleason 3.5, but no human can put that number. So there's still a lot of things needs to be investigated to get all that can be done with AI.
So what would be your recommendation? Let's take this problem of translating scoring into an AI model. What would be your recommendation for the best collaboration between computer scientists and pathologists? How do pathologists explain this scoring best to the computer scientists, and how should computer scientists, what do they need to know? Like, what are the requirements from both sides to solve this problem?
Of course, you can teach this kind of classification, but it's always better that it can be converted to area of something or count of something. This kind of numeric exact things that you calculate area of tumor area inside of stroma or whole tissue, this kind of tumor burden. So if the scoring, it needs a discussion between the pathologist and computer scientist. That can it be converted this kind of exact pixel number, so area of micrometers in pathology or number of cells compared the biomarkers like Ki67 are much easier. But actually when you need to detect also the epithelium or cancer epithelium, then it's what is the border between cancer epithelium and benign? So there's always this kind of, they're not easy to anybody.
No.
So how to convert, because current pathology systems are designed, or the scoring system are designed for humans. You can fastly do good enough diagnosis. So it's a Gleason 5. You have 3 minutes or 5 minutes time to score it. So there's no possibility to count 1 million lymphocytes in cancer.
No.
So, and also the discussion is important because then the AI can do the counting of the areas or counting of the cells. They can do the whole slide. Is it 1,151 lymphocytes or positive Ki67 cells? And count the area of the tumors. Then it's that how the current system of grading can be converted. So it needs a long discussion. Example, Gleason grading, there's a different opinions. I have talked it how it can be converted. Like opinion that Gleason grading, do you estimate in gland level or subgland? Because some part of the gland can be Gleason 5 and 3 made patterns. So patterns are not, or do you need this kind of 500 micrometer area that is same? So what is that way basically this kind of fast visual diagnosis that is done in multiple level of the zoom and multiple areas, how it can be converted to this kind of common rules? I think that there's a lot of discussion to be done.
Yes, and I think there is not always one answer that is correct. It may be that, you decide for something and another team is going to decide for something else, because like you said, the current scoring is designed for humans to do it fast under the microscope. It's not always the best. It's not always objective. This is basically the best we could come up with before we had the tools that we have now. And now translating this into our tools it's a totally different challenge. So thank you so much for presenting this to us and for pointing this out to the listeners. I think this is really important. I think this is something that's underestimated, and the thing that you mentioned, that pathologists visually normalize the scores, so often they are higher than the pixel count. I don't think we're always aware of that, and then like you said, there can be misunderstanding between, okay, is the model is not matching the ground truth. So if our ground truth is annotations, it's a different story, but if our ground truth is scoring, that's another problem.
There's a lot of things that needs to be, and there's a couple of dangers even that you change the scoring that the hospital is used, the oncologist is used to. So there's a lot of practical problems coming up when the AI is utilized in clinical, and there's no global ground truth for many of the scoring systems, at least for the grading systems.
Yes, I think that means that computer scientists and pathologists are bound together for a long term if we are to use AI to power pathologists. So we just keep improving our communication. Thank you so much for joining me today, Thomas.
Thank you for the invitation. It was nice to talk with you.
Have a great day.
Okay, thank you.
I want to thank Aiforia for sponsoring this episode. To learn more about their offer, please visit their website at aiforia.com, and I will include this address in the show notes. Thanks for listening. For more great digital pathology resources, visit the Digital Pathology Place website and subscribe to our newsletter on digitalpathologyplace.com. After subscribing, you will get access to the free digital pathology crash course, which will help you start working on your digital pathology projects immediately. Talk to you in the next episode.